So tonight I wanted to talk about a passion project of mine in a new space that's been rapidly gaining popularity in the indie gaming development communities. So my name is Jesse Freeman. I'm the head of developer relations at Samsung Next. And before I got into developer relations and even evangelism, I started building websites in the early .com days. So my background comes from building websites for Arista Records, the New York Jets, Major League Baseball, HBO, and more. And eventually I made the switch from building websites to my true passion, which was game development. So I joined Microsoft and Amazon, and over the course of 8 years, worked directly with indie game developers around the world to help them build their own games. And I've tried to be a champion for indie game developers, and I also wrote one of the first books on HTML5 games. So in addition, I also worked on several Amazon teams that helped build hardware and software to allow developers to build innovative and profitable games. But about a year ago, I decided to make another switch and was getting very interested in AI and machine learning. So I joined Samsung Next, and a big part of this motivation was really to see how much further I can push technology. So of course, I approached machine learning like I do any other new programming language, and I tried to see how can I make a game with it. So one of the earliest examples I did was teaching a machine and a model how to actually generate out text adventure stories. And this is an article I wrote for Towards Data Science that talks about how I fed all of the terminal text from a game called Marathon into a model and had it output its own generic text for a game. So currently, some of the stuff that me and my team are working on is how we can pair AI and food. And one of the things is a product that we're working on at Samsung Next called Whisk, which allows developers to tap into a large food database that is powered by AI to help suggest recipes, find ingredients online, and better understand the food that you eat. But this talk tonight isn't really about Jesse today. It's actually about Jesse almost 35 years ago. So this story really starts back in the early 80s when I first started using a computer. And I came from the last generation of kids who remember using computers on monochromatic displays that ran solely from the command line. And while this may have been how I got my start, my true passion for computing began when I got my first Macintosh. And from an early age, I was an artist, drawing, painting, sculpting, until I taught myself how to code and became one of the early pioneers of the interactive web days. So indie games, which gave rise sort of about 10 years ago as I started making the transition into evangelism at Microsoft, really spoke to me because I really liked the idea of these small teams building retro-style games, which reminded me of the stuff that I used to play and build in the early 90s. And so 6 years ago, this indie game aesthetic gave rise to the first fantasy console. Now, a fantasy console revolves around 3 key points. The first is that it's a self-contained development environment. And what that means is that not only is it a place for you to build a game and play a game, but it also has all the tools you need, such as a sprite editor, a tile map editor, and tools for building sounds and even coding. The next is that a fantasy console usually has very strict limitations. These are designed to emulate early 8-bit game consoles. So because of that, there are strict limitations around resolution, memory, graphics, and sounds. And finally, each fantasy console has a very unique ecosystem around it, and that's due in part to the limitations that they have. Since each fantasy console has its own color palette and its own way of rendering graphics to the display, you get very unique games that you can tell come from very specific fantasy consoles. Just like if you look at certain games, you can tell which ones came from Nintendo versus Sega based on the colors and the size of the sprites. So the first fantasy console was Pico 8. And at the time, it was incredibly clear to me how this was the natural counter movement to the large and more complicated game development software tools such as Unity and Unreal. But unlike those tools, Pico 8 was more than just a game engine. It was a entirely self-contained development environment, and I was instantly hooked. But there was one thing that I felt was holding it back. And to kick things off, you needed to use the command line. And while I use Bash daily to commit code, run Node, and execute my automation tools, My earliest days of coding really began on the more user-friendly and graphical rich UI of the Macintosh. So while I learned BASIC and C at an early age, it wasn't until HyperCard that I truly fell in love with merging both my artistic and coding sides of my brain, which later gave birth to my career in web development. So I set off to build my own version of a fantasy console called Pixel Vision 8. And not only did I want to make a more user-friendly development environment for people like me, I wanted something more approachable to generations of developers that came after me and grew up where design, UX, and rich UIs were at the forefront of the computing experience. So while it's easy to build a clone of Pico 8, in fact, there are lots of them out there, my vision was to push the concept forward. And to do this, I built a custom engine from the ground up and an OS on top of it that supported a desktop, disks, allowed customizing the specs, and I made it fully extendable so that people can build their own tools on top of the ones that I created. In short, I wanted a fantasy console that was completely customizable with modern workflows. So Pixel Vision 8 is built in C# with a Lua interpreter that's sitting on top and exposes the underlying game engine's APIs. And what this allows you to do is to build games in Lua without having to recompile in order to see the changes. And this is pretty common with fantasy consoles. A lot of them are written in a lower level language, and what you get to use is sort of a scripting language on top to make iterating through game designs rather quick and fast. So since the Lua APIs are also the same as the C# ones, it offers an upgrade path to easily port to C# if you want more power or you want to add features that are not actually part of the core Lua API set. And what this means is that there's complete parity. And one of the frustrations I saw with modern fantasy consoles is that once you built a really great game, you were sort of stuck in that little sandbox. So if you wanted to turn that into something bigger, there really was no way to do it unless you ported it to some other game engine. With Pixel Vision 8, all you need to do is take the same APIs that you're using in Lua and just port the differences between the two languages over to C#, and you can now build on top of MonoGame. So because of this shared API, there's a consistency between both of the different types of coding languages you can use to build your games. Because really at its core, I didn't want to lock developers in. And while Pixel Vision 8 has its own built-in tools, I really created a workflow that allows you to use external code editors and create artwork with your own art tools as well. In fact, I actually released an Atom plugin that offers the Lua API code completion. I don't want you to be locked into anything, so use the tools that you're comfortable with, or try to use the ones that I've been building inside of the fantasy console. So I'll talk a little bit about the architecture. At its core, Pixel Vision 8 is built around this modular set of chips, and they control everything from the screen's resolution to how many sprites can be displayed to what kind of sound effects are played, and even how things are rendered. You can even build out a cart chip that gets a limitation on how big a game can be. So, and each chip is implemented with a C# core engine, and they're designed to be easily swappable. So what that means is that as long as you implement the iChip interface, you can actually tap into the engine's native update and draw methods. So in this case, when you go to build a C# game, you wind up getting just a game chip. And if you want to build a Lua game, you wind up getting the Lua game chip, which adds in the Lua interpreter and exposes the APIs to the Lua side of things. You can do this for anything. If you wanted to build your 3D engine inside of Pixel Vision 8, you can actually build a new display chip that would handle that as well. But I want to talk a little bit about rendering, because one of the big challenges of building an 8-bit game engine on top of modern game engines is rendering. I grew up specializing in something called blitting, and I wrote lots and lots of blitting engines. And basically what blitting is that you draw pixel data directly to the display. So I did this throughout my Flash career, and it allowed me to bypass the slow vector rendering in Flash. And I actually created one of the first early 3D websites with it. But the downside of it is that modern game engines don't really do this anymore. They all use textures and shaders and really primarily are focused more on 3D. So what I wound up doing was building a custom software render. And the reason for that is that I wanted to use some old techniques such as palette swapping. And what happens is that every time a sprite is loaded into a game, each of the color pixels are pointing to a color ID in memory. And what that allows me to do is if I change the color in memory, the sprite automatically changes instantly because it's referencing that color. And you may be familiar with this when you've seen games where you have a green enemy on one level, and then later on, it becomes stronger and it's now red. Also, as you can see from this little animation that I created here, if you want to fade up and down artwork, especially on like a start screen, Mario 3, for example, does this. You can't actually use alpha because 8-bit game engines didn't have alpha. So what you wind up having to do is just change through and cycle the colors out through different palettes, and this can create the similar effect. So another part of it is how I actually display the pixel data. So I use a custom built software render, as I'd mentioned before, and the final output from the Pixel Vision 8's own software render is basically dumped into a texture and displayed on the screen. And some of the other things that I do is I have some shaders that can sit on top of it to give you a CRT filter for a more authentic look. So early on, when I was building Pixel Vision 8, I started using Unity. And I was running into a lot of problems because Unity is primarily designed for 3D games. And trying to just do stuff where you're blitting directly into a texture wound up being incredibly slow. So when I ported it over to MonoGame, which is an open source game engine, I was able to actually strip out all of the 3D stuff and all the parts that I didn't need of MonoGame and whittled it down to its core, which is built around something called SDL2. And this is a very low level game library that accesses controllers, displays for OpenGL, and is cross-platform. And this is really the key to how I'm able to build Pixel Vision 8 and its games cross-platform with very little additional work. So the other big part of the game engine is the sound and the music. So I built a custom sound chip on top of an open source project called SFXer. And if you're not familiar with that, it actually is a set of templates that allow you to randomly create sound effects for a game. I don't come from a music background, so it's really good, especially when you're in a game jam. I usually let the sound and music, I leave that to the very end. So I can just go into SFXer, click a few buttons, and get all the sounds that I need. And this also gave me the idea to, can we extend this into making music? So Pixel Vision 8's music tool is rather unique. While it does have a tracker, and the tracker uses the sound effects for its instruments, what you see here in the animation is that you can actually click this magic wand, and the magic wand will automatically generate music for you. So going back to what I had mentioned earlier about my interest in machine learning, this is an early example of me trying to figure out how can we train and teach Pixel Vision 8, for example, to generate out music. So a lot of the music it creates isn't very good, but it gets me close enough to go in and start cleaning it up by hand, when normally looking at a blank tracker sort of intimidates me, and I wouldn't even know where to begin. So the other thing I'll mention too, what I find interesting and why I'm fascinated with machine learning is the idea of, well, generating music is pretty simple. One day I hope to be able to create artwork or have the Pixel Vision 8 even generate out levels or play test them for you. So all of these are things I've been seeing online that people have been experimenting with. And eventually this might be easy enough to just implement into not only my game engine, but other game engines as well. So next I'll talk a little bit about input. And the way that I've handled input in Pixel Vision 8 is that I exposed 3 different input methods. There are controllers, so you can plug in USB or Bluetooth controllers. There's keyboard support for entering in text, and then there's mouse support. And one of the things that I wound up having to do, especially when I was switching over from Unity to MonoGame and trying to build out a very simple input system, was that I wound up abstracting out the way that input works through the controller chip. And what winds up happening is that there are a set of core APIs that hide all the complexity of dealing with input. It makes it easy where all you have to do is say, is button A been pressed or released? And you can do the same thing with any key or with the mouse. But the most important thing for me was the desire to make all of this open source so that I can contribute to the community, and also that others can take what I've built and maybe build their own fantasy consoles on top of it. So from the very beginning, the whole reason for me building this modular architecture was to allow other people to go in and customize and do what they want with it. So there isn't really a lot of time for me to go into actually building a game, but what I do want to show you is a quick example of just how to compile the code from scratch. And before I dig into that, what I want to show is if you go to pixelvision8.com, what you can actually do is download a copy of the pre-compiled version, and this has everything you need to start building a game built in. It has the operating system already configured and installed. It has Pro Tools, which I've recently just made free during what's going on with everything. I want people to make more games, and I'll talk a little bit about that later. And also there's documentation and code examples, and you can go and click on the source code. So when you open up the source code and you go to GitHub, you'll see the project, all the commits and everything that's going on. Master is always the most stable build. And below is instructions on how to actually build a simple C# game using the included project. So I'll switch over real quick. I've already gone ahead and downloaded it. And when you open it up or you clone it to your computer, what you'll wind up seeing are a few different Visual Studio solutions. The first one is a MonoGame runner. And what this does is a project that includes a simple C# runner and a simple Lua runner. And this shows you a way to just either build a C# game from scratch or a Lua game. There's a way of generating out DLLs if you want to incorporate Pixel Vision 8 into another project. But the one I'm going to talk about right now is the Pixel Vision 8 runner. And this is actually how to build and compile the entire operating system from scratch. So I'll switch over to Visual Studio. If you're using a Mac, you can use Rider. And all you need to do is, once you download the project, go into the references, and you'll need to probably fix the NuGet packages. So there are two of them that I use. One of them is called SharpZip, which is for dealing with zipping up the disk files. And the other is called MonoVision, which is another open source project that allows me to use the Lua interpreter. And then once all of the references are set up, all you need to do is hit start, and it'll go ahead and compile it for you. So as you see, it'll boot up into Pixel Vision 8, give you all the credits for everyone who's helped contribute to the project, and then you'll see this error. So since we're building it from the source code, the operating system isn't included with the build, so we're going to have to actually just mount it off of the disk. So inside of the project folder, there is a disks folder, and you'll see Pixel Vision OS. We simply drag this onto the window. You'll see the disk gets inserted. And if this is your first time using Pixel Vision 8, it'll ask you to create a workspace on your computer where you can access the files that Pixel Vision 8 are editing. And then if you hit OK, it'll create your first project for you. So inside of this, you'll see all the different files that make up a game. Each one of them is associated to a unique editor. And if you hit run, you'll see your first Hello World project. Going quickly, you can simply just open up the code editor here and type in the code that you want, or you can use an external code editor. There are tools for building out custom colors and system palettes. So here is a full color picker if you want to design your own custom colors. One of the other things that I'm really proud of is this idea of, I talked about the chips under the hood of how the C# engine works, but on the Lua side of things, there is a chip editor. And what this does is it allows you to pull out some pre-configured chips. So there are different settings for the Nintendo, for the early Master System, even the Game Boy. You can change out the cart types, which change the size and also how big of a tile map you can have. And you can even change out the sound renderer. So what happens is, even for sound, you can go through and define what audio channel plays what wave sound. So, and I won't be able to go through all of these, but there is a built-in font editor. I talked about the text editor, and then there's also a built-in sprite editor and a tile map editor. So all of these things are here to help you build your own games. And the other thing is that there's a full set of documentation. So on the GitHub project, there's actually a wiki, and the wiki has everything you need to get started with a C#. But if you go to docs.pixelvision8.com, it'll show you all the documentation for either building a game in Lua or C#. And there's a full set of API examples. So every single API example has a project, and the projects will show you how to run them and do the code in either Lua or C# and give you a preview of it. So the reason I talk about documentation is an important one because when building a fantasy console on my own, it's been like an incredibly time-consuming project, but it also has a lot of non-technical challenges as well. So one of the things is having to build all the documentation for the game engine, for the tools, for the operating system, the workflows, and all these other things. So a lot of the content overlaps and is shared between different places based on the context. So I started treating my documentation just like I would building any code project. So I built a series of scripts on top of Google Docs that allow me to combine multiple docs, convert them into Markdown, and output different formats. So one output will go to Gitbook, and the other one can go to GitHub Wikis. And this allows me to keep all the documentation centralized in one place. And whenever I need to update it, I can just easily push it out to either of the different locations. But perhaps the thing that I'm most proud of, and one of the things that I love building automation tools, is a tutorial generator. So I wrote a plugin in Atom that allows me to actually take code examples from Lua and convert them into step-by-step instructions. And this is sort of based on the idea of a decompiler, but instead of it giving you back code, it unwraps the code and gives you these step-by-step instructions, including line numbers, and will tell you if you enter a function, what code goes in, and also how it changes the line numbers as you go through the tutorial. And what's really cool about this is that as I'm writing code, it automatically is updating in the window next to it. So I get a live preview of the tutorial I'm writing. And this means that I get to focus on what I really love most, which is writing little games or code examples, and the tutorials automatically get generated while I work. So Pixel Vision 8 has been a nights and weekend project for the past 5 years. And throughout the project, I've collaborated with 2 developers, 3 pixel artists, and maintained the project both on itch, GitHub, and my own site. And while this isn't something that I set out to make money with, a big motivating factor for me was to be able to help support a lot of the indie developers and artists that I love, with them also being able to contribute back to Pixel Vision 8. And collectively, what we've been trying to do is push the fantasy console space forward in a meaningful way. So while I continue to build a healthy community of developers using my background in game dev and evangelism, I'm proud to say that we now have over 5.6 thousand active users and 3.7 thousand users on Twitter. So, and I was also one of the first developers to get a verified Discord channel, and I try to be as active on it as possible. There's a good community of people who are out there who are willing to help you. And if you have problems, you can go on there if you're just getting started. But a lot of the things that we also like to see are, what are you doing? What are the works in progress? And you can share that with the rest of the community on the Discord channel. In fact, Ludum Dare, which is a very popular game jam that happened the past weekend, I set up a special channel for it. And myself and a couple of other developers were constantly sharing back our feedback and sort of what we were doing and the games that we were building with Pixel Vision 8. So this brings me really close to the end of my talk. And I'm sure you've heard a lot now lately about how this is really unprecedented time. So I live in New York, and we've been hit especially hard by everything that's been going on. So it's actually been over 8 weeks since we've been able to leave the house. I wouldn't notice because as long as I have a computer and some video games, I'm pretty content just staying inside. But I think the rest of my family is itching to get outside. But that being said, it's never been a better time to build a game than now, especially if you've always wanted to, or if you have a project that's been sitting on the back burner. Use this time to create and build out your skills. I mentioned really early on in the talk that one of the things that I've always done when I learned different programming languages is that I started by building a game. And while some people may not know what the future holds, especially if you feel that you're going to lose your job, or maybe that you want to have a different job when things calm down, I highly suggest picking up a game engine. It doesn't have to be Pixel Vision 8. It could be any other game engine out there. There are so many different game engines in different languages. And just start building games. And maybe the game itself is not the end result. It may not give you the skills that you need, particularly to go into the game industry, but it may give you the skills to be a better developer. And since a lot of my time running a team of evangelists really revolves around management, using this project has been able to keep my development skills sharp and also share things back with the rest of the community. So please take the time, be productive, be creative, and use it as an outlet. I much rather sit at home and code and build games than watch TV and do other things that are passive. So create, create, create. And that being said, this sort of gets me to the end of the talk. Hopefully this is enough to interest you into giving Pixel Vision 8 a try. It's still a work in progress, and I try really hard to push out new updates and bug fixes every few months. Again, since this is a nights and weekends project, I'm not able to do it as much as I would like to, and there are still things that are very buggy. I'm very close to reaching a beta. We've been in alpha for a very long time, over the past couple of years, and I really strive hard to build really good code examples and documentation. So all of this is out there, and it's ready for you to poke around, to take a look, and to build something fun. And if there's anything that you run into, any problems, feel free to go to the website. There's a way to message me on the website. You can email me directly. The email is below, or even reach out to me on Twitter and, of course, the Discord channel. And again, just for me, this has been, I sort of joke around with my friends that I've hit my sort of midlife crisis. And while some people go out and they build, they go out and they buy expensive sports cars, or they, go through and change their entire lifestyle. One of the things that I've tried to do is actually just build my childhood. And that's like the thing I think I'm the most proud of when I look back at the last 5 years of working on this project, because some days it's frustrating when I don't feel like I'm making the progress. But other days, when I can sit down and I can play with the operating system, I can go into the tools, I see things work, I see other people creating stuff with it. And it really gives me that sense, at least I feel like I've captured what really got me into computers to begin with. And that was that curiosity, that fascination of opening up an empty text file and turning it into a game, using my ability to create art, mixing it with sound, doing coding, even writing the story that goes along with it. All of these things have now become the art outlet that I've always had as a child. And it makes me so happy just to be able to play around with something that really reminds me of my early Macintosh days. So that being said, I'm going to wrap up just a little bit early, but I'm going to hop on over into the chat and I'll hang out for a little bit. It's a little bit late here in New York, but please feel free to reach out. Even if you don't make games now, I'm always happy to point you into the right direction. I've done lots of Lynda courses. If you go to lynda.com, or I think it's called LinkedIn Learning, I've done almost 30 courses now on game development and programming. So there are lots of resources out there that I've done, as well as others to get you started. And with that, I want to thank GitHub and everyone else for having me come and speak. And I appreciate the time, and hopefully you like the talk.